Hey, we're on film. We're back with 7-4. It's a conditional probability. This is when the probability of an event changes when something happens before it. And here's a typical example, something like what you might see in a homework problem. It says, suppose you've got a class of 30 students. You know, you've got 18 boys in the class. It also has 12 students that play basketball, and 5 of them are boys. All right, so then it'll say, what's the probability that you just choose a girl at random? All right, well, if you go back to the original definition, it's the things you're interested in over the total. If there are 30 students and 18 are boys, that means we're going to choose from amongst 12 girls out of a total of 30. You can, like I said before, write it as a percentage, or you can try to simplify it down. It would be 6 out of 15 or 2/5. Okay? A little bit more difficult, though, is this one that says the probability of a girl, and then with this thing with this line and BB, and what's that all about? That is often very confusing. This line, you interpret this as meaning given that this has already happened. Okay, so what this is, it means the probability that we've got a girl if we know that we're choosing from amongst all the basketball players. All right, so you say, all right, well, if we've got 12 students who play basketball, that means our total is 12. 5 of them are boys, so it means that 7 are girls. So this is 7 out of 12 total basketball players. It's all about knowing what that line means. To do problems like this, though, sometimes it's easy to draw a little chart, and I haven't left myself a lot of room here. But if you do something like this, and I think it'll go like that fairly easily, where this is like boys, and here are girls, and here's basketball players, and then not playing basketball players. We know that the boys are going to add across to be 18, like this. We know that the girls will add across to be 12. We know that the total down here is 30. We know that the basketball players will total to be 12 this way, and not basketball will also total to be 18. Kind of a poor choice of numbers because these are not related to these numbers, but you should be able to sort that out. Boys playing basketball are 5. So not playing basketball then amongst the boys would be 13. Girls playing basketball is going to be 7, and not playing would be 5. Okay, so if you fill in a chart like that, then it's just a matter of saying, all right, 7 out of, in this case, if all the basketball players, if all the basketball players are 12, it'd be 7 out of 12 there. All right, so now a different question related is this one over here. And here we say, suppose a bag holds 7 black and 13 white marbles. What's the probability that we choose 3 black marbles? That means reaching into the bag and choosing 3 and looking down at your hands and have all 3 be black. Well, choosing 3 marbles all at once is no different than if you choose 1 and then another and have 3 in your hand and then look at them. And so it makes it much easier to break it down by 3 individual probabilities. And then when we have probabilities like this, we just simply multiply the results. So the chance of choosing 1 black marble as my first one is going to be 7 out of a total of 20. Okay, 20 total marbles, 7 of them are black. Now the next probability, if I'm holding a black one in my hand, means that there are only 6 marbles left that are black out of a total of 19 marbles. That's the critical thing you have to realize, that this probability has changed this one. If I've chosen a black one, there's 1 less to choose. And then finally, if I've chosen 2 black marbles, which I have to get 3 of them, then it's 5 out of 18. And that's my final setup, but now I just do the multiplication. Sometimes it's easy to cancel. I can cancel the 5 and the 20 and write a 4. I could cancel the 6 and the 18 and write a 3. But I'll let you do the actual math. You just multiply 7 times 6 times 5, put that total over 20 times 19 times 18, use parentheses, and you're good to go. Thanks a lot.